Hi students. Moving on with the slideshow, we're going to do Newton's second law of motion. Let's begin. This law is best example as an equation. Force equals mass times acceleration. In words, Newton's second law of motion can be formalized standards as follows. The acceleration of an object as produced by the net force and necessarily properties to the mass of the object as force goes up, acceleration goes up. As mass goes up, acceleration goes down. As you can see, we have a little diagram of people pushing stuff, such as diagram A, pushing a car. Force is on the guy's head, and then acceleration pushing towards the car. Force on the force on the guy's head once again, and force on the guy's head, and acceleration on the push mower. Acceleration. Newton's second law of motion explained. How much force is needed to accelerate a 70 kilogram rider and her 200 kilogram motorcycle at 4 miles. What is a Newton? Force, mass times acceleration. Force equals mass times acceleration. Force equals kilometers times mass, whatever, and so on and so forth. Example, pushing a shopping cart. Let's watch this little video. Or whatever it is. Sorry about that. I guess we're not going to be watching this video. Gravity. What is gravity? The force in the universe between all objects. Every object in the universe has a force on other objects. Gravity force. The amount of force that gravity exceeds is called gravitational force. How much gravitational force there is on the mass and distance between objects. A gravitational force example. Earth is larger than the moon. The force the moon is stuck in between the gravitational pull of the moon. Acceleration caused by the force of gravity, Gravity is a force that pulls objects towards the center of the earth. Center of an object. Near the earth's surface, gravity causes all falling objects to accelerate at 9.8 miles. Acceleration due to gravity is the same for all objects. The bowling ball and the farther. If acceleration due to gravity is the same thing for all objects regardless of mass, then what is then then all what all objects should then all objects should fall at the same rate. Same rate, excuse me. Does a leaf fall as fast as whatever this is? Air resistance. Two objects will only fall at the same rate if no other force is present. For example, in outer space on Earth we have air resistance. The force that air exerts on a moving object, the force acts in the opposite direction of the object's motion. Air resistance. The amount of air resistance on an object depends on the size, speed, shape, and distance, whatever, on the object. Gravity and weight. The measurement of the force on gravity on an object is weight. Weight is different from mass. Mass versus weight. You can look at this. I'll give you a few seconds to look at this. Pause the video here if you need to. Mass versus weight. Mass is not a force, it is a quality. Weight is the force of gravity on an object. A mass of 1 kilometer weighs 9/8 of a Newton. How do I calculate weight? Because any force can be calculated using the equation F equals m times a. Weight of an object A force can be used in a similar equation. W equals mass times acceleration. Weight equals mass times acceleration. Because weight is the force of gravity on an object. The rate of acceleration pull is the pull of gravity. Remember, 9.8 miles, whatever. Weight example. You can look at this. Newton's third law. For every action there is an opposite and equal reaction. For example, if you hop out of a boat and the boat stops or whatever, force on your feet will be pushed forward, although enough your exert an equal and opposite force on the boat, sending it backwards. Newton's third law. For every action there is an opposite. There is a reaction equal in strength and opposite direction. Unbalanced reaction pairs. Sometimes actions and reactions forces are not balanced. For example, if a toy truck rolls towards you, you can stop it with your hands. The force of the truck is not equal to the force of your hands. Let's watch this little video.
An object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion continues in motion unless acted upon by an unbalanced force. Let's say you walking down the street cause you're going to the mall and something knocks you off your feet cause you ran into a wall. So you were acted on by an unbalanced force, which means you ran into the wall and it threw you off course. Oh, I get it now. An object at rest.
So you get the point of that video. Bye, students. Bye-bye. Bye.